Determine the magnitude, direction, and position of the resultant of the coplanar non-concurrent force system shown in figure. First, let us find out this angle theta. This angle is given by tan inverse of opposite by adjacent. We get theta as 63.43 degrees. Now writing theta value. Now resolving forces horizontally and vertically, summation Fx and summation Fy. First, this force 4 kN is acting towards positive x-axis. So 4 kN acting towards positive x-axis. This force Phi sin 63.43 degrees acting towards negative x-axis. So 5 sin 63.43 degrees acting towards negative x-axis. So minus, and this force 6 kN acting downwards towards negative y-axis. So minus 6, and this force 5 cos 63.43 degrees acting towards negative y-axis. So 5 cos 63.43 minus. Now calculating all this we get summation fx value. Calculating all this we get summation fy value. Resultant is given by r equal to square root of summation fx square plus summation fy square. R we get as 8.249 kilonewtons, and resultant direction is given by tan inverse of summation fy by summation fx. Theta equal to we will get 86.72 degrees. So based on summation fx and summation fy values, we see that summation fx is negative, summation fy is negative. So this will happen in the third quadrant, and resultant is having a magnitude of 8.249 kilonewtons and making angle 86.72 degrees to the horizontal. Now taking moment of forces about point D, this force 4 kilonewton will have line of action of force like this, and it will travel along line of action of force and passes through point C, and it will have perpendicular distance this much 1.2 meters, and it will rotate like this about point D clockwise movement. It will form a clockwise movement of magnitude 4 into 1.2 meters. Now this force will have line of action of force like this, and it will travel along line of action of force like this, and it will be having perpendicular distance from point D of 1 meter, and it will rotate like this anti-clockwise about point D, and this force will have line of action of force like this, and it will travel along line of action of force and passes through point D, and so it will have zero perpendicular distance from point D. So this force doesn't have any moment about point D because its perpendicular distance about point D is 0, and it is already passing through point. So perpendicular distance is 0. So moment about of this force will be 0. Now, this force phi cos 63.43 degrees will have line of action of force like this, and it will travel along line of action of force, and it will pass through point A like this, and it will have perpendicular distance of 2 meters from point D, and it will rotate about point D like this anti-clockwise. So it will have a moment of 5 cos 63.43 into 2 rotating about point D. So it will be anti-clockwise moment. So minus. Now calculating all this, we get moment about D as this value and D this D, and another moment couple. This is another couple having magnitude of 8 kilonewton meter about at point D. So this is having anti-clockwise rotation. So minus 8. Calculating all this, we get summation MD D. This D equal to summation MD by R. This D is perpendicular distance of resultant from this point D. It substituting this value and R value, we get perpendicular distance of resultant from point D. X-intercept is given by summation MD by summation Fy. So substituting summation MD value and summation Fy value, we get X-intercept, and Y-intercept is given by summation MD by summation Fx. Substituting summation MD and summation Fx value, we get Y-intercept. So what we have is summation Fx value, summation Fy value, R value, theta value, D value, X-intercept and Y-intercept. Summation Fx and summation Fy are negative, so resultant is in third quadrant and having magnitude of 8.249 kilonewtons and making angle of 86.72 degrees. So X-intercept from point D is 1.659 meters and Y-intercept from point D is 28.964 meters, and resultant is having magnitude of 8.249 kilonewtons, making angle of 86.72 degrees.